Hey, 20-2s. What we're going to look at in this little video is we're going to continue talking about radicals, but in this video, we're going to talk about mixed and entire radicals. Okay, what's a mixed and entire radical? Well, an entire radical is going to look something like this, say the square root of 20, and a mixed radical will look something like this, 2 the square root of 5. Well, guess what? These two things are actually equal to each other. So our job today is to look at mixed and entire and how do we switch forms between these two things. Good news is it's actually pretty simple. Wait, what are mixed and entire radicals and why the heck do we care? Okay, here's two entire radicals. And I know if I asked you the square root of 9, you would tell me it's 3. And if I said, what's the square root of 25? I would tell you it's 5. These are known as exact values, meaning I know exactly what it's equal to. But when I ask you what's the square root of 20, okay, I don't know what the square root of 20 because it's not a perfect square. So if I go and put that in my calculator, I'm going to get this big, long list of decimals. Look at this. This is nasty. And it actually keeps going on forever. It never stops. It's irrational. Okay, this is not an exact value. And as mathematicians, we want exact values. We don't like to round or truncate. Okay, it can start causing really big problems for us later down the road. So the reason why we want to work with radicals is radicals give us exact values. So we would prefer to write an answer as the square root of 20 than to write this big long mess right there. Okay, so that's why we care. We want exact values. As mathematicians, we don't like to round, we don't like to truncate. Now, what's really, really important for you in this unit is you have to know a bunch of perfect squares and cubes. So what I would do, my friends, is I would actually, in this unit, write these all out somewhere. Okay, if you don't have them memorized, I want you to write these out. Okay, so all I'm doing here is I'm saying to myself, there's 9 cubed, there's 10 cubed. You should be able to go all the way up to 12 cubed, just like that, or 12 squared, sorry. There's your perfect squares. If you want your perfect cubes, so let's go hot pink. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. 6 cubed is 216, and you could keep going, but usually if you get all the way up to 6 cubed, you're in pretty good shape. So if you don't know your perfect squares or your perfect cubes, let's write those out somewhere. They're really going to help you in this unit, big time. All right, now that we've done that, we got those written out. They're on a sticky note. They're on the wall. I'm looking at them. Let's do this. Convert the following mixed radicals in simplest form. Okay, so here's what this means. Right now, we have 2 entire radicals. We're going to switch these to mixed radicals. So what I'm going to do is I'm going to go back up to my list of perfect squares. And I'm going to say which of these perfect squares is the largest factor of 72. Well, I'm just going to switch pen color to red. 36. Look at that. 36 is a factor of 72. So I'm going to rewrite this as 36 times 2. Then what I can say to myself is this. Well, I know what the square root of 36 is. The square root of 36 is 6. The square root of 2, I don't know. There it is. That's 6, the square root of 2. That's how you do it. Let's try square root 80. Okay, square root 80. So I say to myself, what's a really large perfect square that divides into 80? That's a factor of 80. Well, the only one I can see is 4. So I rewrite 80. I'm just changing how it looks. I'm not changing what it's equal to. That's 4 times 20. I can say to myself, the square root of 4 is 2. And the square root of 20, I don't know. Okay, but wait a minute. Oh no, I noticed the square root of 20. Well, wait, there's a perfect square. That's a factor of 20. perfect square that's a factor of 20 is 4. Well, that's 4 times 5. And the square root of 4 is 2. So I'm going to bring this thing out front now. And 2 times 2 is 4. There it is. The square root of 80 is 4 root 5. Now, I did that one the long way. I'm going to do this one a different way. Let's do it right here. Square root of 80. Well, this time what I want to notice is that 16 is a factor of 80. 16 times 5. And the square root of 16 is 4. So guess what? It's really 4 root 5. What do you notice? We get the exact same answer both times. Isn't that neat? So 2 ways to do it. The quicker way is to always find the larger perfect square. Okay, let's try a couple more. So next one here, 5 the square root of 20. So what I say to myself is the perfect square that's a factor of 20 is 4. So 20 is really 4 times 5. The square root of 4 is 2. So I go 5 times 2, 10 root 5. Just like that. Okay, now, how do I check my work? Well, checking my work's actually really easy. Okay, what we're going to do is we're going to grab our calculator. So I'm going to pull mine up here. Okay, and I'm just going to go back to my main screen, just like that. And watch what I'm going to do. I'm just going to check my answer. So let's say we did earlier the square root of 20. So I put the square root of 20 in my calculator. Gives me that long, ugly decimals. Then what I want to do is simply check my answer. So I put my answer in my calculator. And do you notice I get the exact same thing? That means I did it correctly. So that's how you're going to check all of your work, my friends. Easy as that. Pretty cool, hey? Wait, what about if I asked you a cube root? Well, for a cube root, nothing changes. So I'm going to do the exact same thing. I'm going to say, okay, what's a perfect cube? That's a factor of 72. Okay, well, that happens to be 8. 8 times 9. And I say to myself, the cube root of 8 is 2. What am I left with? A 9. Now, I purposely made a mistake here. I left off the index. Do you see that? I don't have that 3 there, that index. You need that or else you will lose marks because then you're telling me it's a square root. Okay, so that's a big no-no. Don't do that. Okay, friends, that's how you switch from an entire to a mixed. And we want to be in mixed because that's called our simplest form. Now, sometimes we want to go the other way around and we want to go to entire. We don't want to do this that often, but we will in this unit. You'll be asked to. This is the easier one, friends. So when it says entire, it means I want everything under the radicand. So somehow I've got to say, okay, how do I get that 3 underneath the radical? So what I'm going to do is the inverse of square rooting is squaring. So if I want that 3 in there, guess what I'm going to do? I'm going to bring it underneath by squaring it. And that's 9 times 7, which is 63. Just like that. Easy peasy. Okay, the next one here, every once in a while they try to trick us and they try to put this negative out front. Okay, all you're going to do when you see that negative is you're going to leave that negative out front because we can't take the square root of a negative number. But the 5 I'm going to bring underneath my radical sign by squaring it. So that's 25 times 2. And guess what? That's negative root 50. There it is. Okay, that's how it goes, my friends. So switching from mixed to entire is easier because you don't really have to find any numbers. You just square or cube the number that's on the outside. But going the other way around from entire to mixed is much more important and more difficult. So that's where you're going to focus your time in your homework today. Okay, hope that helped. I will see you next time.